Hello everyone. In this presentation, we will be talking specifically about the movements at the synovial joint. Professionals who study the science of human movement, they will use specific terminology to identify the movements that can occur at a synovial joint. And these terms may indicate a few things, like the form of motion, the direction of the movement, or the relationship of one body part to another during a specific movement. In addition, these movements can be grouped into four main categories, which are gliding, angular movements, rotation, and special movements. Let's talk about all of these in more details in the next few slides. First, we're going to be talking about the gliding movements, which is mainly a simple movement in which nearly all flat bone surfaces move from side to side and back and forth with respect to one another. There is really no significant alteration of the angle between the bones, and this gliding movement are going to be limited in range due to the structure of these articular capsules and associated ligaments and bones. In addition, these sliding movements, they can also be combined with rotation sometimes. Now, the intercarpal and intertarsal joints are examples of articulations where gliding movements occur, where inter means between, and carpals are the wrist bones, tarsals being the ankle bones, as seen on these images to the right. Next, we have what we call angular movements. And like the name says, there's going to be either an increase or a decrease in the angle between the articulating bones. So the major angular movements are going to be flexion, extension, lateral flexion, and hyperextension, in addition to abduction, adduction, and circumduction. When we do discuss these movements, they're always going to be with respect to the body in an anatomical position. So remember to keep this in mind. Here we have flexion and extension, which are going to be opposite movements. In flexion, which flex means to bend, there is going to be a decrease in the angle between the articulating bones. In extension, where extend means to stretch out, there's going to be an increase in the angle between the articulating bones. And often, this extension will be to restore a part of the body to actually the anatomical position after it has already been flexed. So this means that most of our body parts are actually extended when in an anatomical position. And both movements usually occur along the sagittal plane, and all of the following are examples of flexion. As you have probably already guessed, extension is simply the reverse of these movements. First, we have the bending of the head over here. As we can see, when they bend forward, it's going to cause flexion at the atlanto-occipital joint, which is the joint between the atlas and the occipital bone. And also, because you're going to move the neck region, there's going to be a movement of the cervical intervertebral joints as well. When you move your head back to anatomical position, then you're causing an extension. If you move it further back, then that would be a hyperextension. On the second image, we have the shoulder joint. Your arm is going to be down in an anatomical position at an extension position. When you bring your arm up, you're actually causing flexion because you're actually decreasing this angle right over here at the shoulder joint. And then when you pull it back down, you're causing extension of the arm at the shoulder. If you pull it even further back, then you're causing hyperextension at the shoulder. So this can be a little bit confusing, but if you keep in mind that in regards to the shoulder, your arm is actually at 180 degrees from the sagittal plane right over here. So this means that when you move again your arm up, you are decreasing this angle, therefore flexion. And if you move your arm further down, you are increasing the angle, therefore extension. For image number 3, we're talking about the elbow joint. When you bring your forearm up, you're actually decreasing this angle, so it's flexion. When you bring it back down to anatomical position, it will be extension. There's no hyperextension at the elbow because the elbow joint prevents your forearm from moving further back. Here on the next one, we have the wrist joint. If you pull your palm up, you're decreasing this angle. So this would be flexion. When you pull it back down in anatomical position, it will be extension. And if you continue pulling it posterior, it will be hyperextension. On the next one, we have the hip joint. So this would be your anatomical position. If you pull it in this direction, you're going to be decreasing this angle over here. So that would be flexion. When you pull it back in this direction, this would be extension. And if you pull it even further back, that would be hyperextension. With regards to the knee, it will be similar to the elbow joint, where the only thing that you can do is flexion and extension. But the knee joint is opposite to the elbow joint. So notice how for you to do flexion at the knee and decrease this angle is actually moving your leg posteriorly. So this would be flexion, and bringing it back to anatomical position would be extension. Last, we have the lateral flexion, which is going to occur between the intervertebral joints, where you're bringing your torso to one side, and then if you bring it to the other side, will be lateral flexion as well. Next, we have abduction and adduction. It can be a little bit confusing, but if you remember that adduction means that you're adding, so you're bringing it closer to your body. And abduction means that you're moving it away. So when you abduct somebody, you're taking that person away. The same thing with the body movements. When you're abducting, you are moving the bone away from the midline. And when you're adducting, you're adding, so you're moving the bone toward the midline. And both will occur actually on the frontal plane. So on the first one, we have the shoulder joint. Therefore, when you bring your arm away from the midline, you're causing abduction. And when you bring it closer to the midline, you're causing adduction. Same thing occurs at the wrist. So this is your midline. If you're bringing it away, see how this is your thumb. So you're moving it away from the body. This would be abduction. If you're bringing it closer to the body, it would be adduction. For the hip, similar to the shoulder joint. So this would be your hip joint right over here. If you move your thigh away from the midline, this would be abduction. If you bring it back to the midline, it will be adduction. With regards to the digits, you can have adduction when you spread your digits out. And when you bring them back in close to each other, you're causing adduction. And on the digits, this will occur between your metacarpal and your phalange. However, we don't include the thumb because the thumb will be a different type of joint, as it is a saddle type of joint, and we'll talk more about this later on, what the saddle joint will be able to do. Circumduction is going to be a movement of the distal end of a body part in a circle. So circumduction is not an isolated movement by itself, but it's actually going to be a continuous sequence of a few movements together. And these movements are going to be deflection, abduction, extension, adduction, and rotation of a joint. Here we have a couple of circumduction. We have one at the shoulder where you can see how they're going around in circles right over here. So this would be circumduction. And also at the hip where the thigh is moving in a circle. So this would be circumduction at the hip joint. In rotation, you're going to have a bone revolving around its own longitudinal axis. One example will be turning your head from side to side at the atlantoaxial joint, which is the joint between the atlas and the axis, or C1 and C2, as when you shake your head no. Another is turning your trunk from side to side at these intervertebral joints while you're keeping the hips and the lower limbs in an anatomical position. With regards to the limbs, the rotation is going to be defined relative to the midline. So on the middle one, where we're moving at the joint, you can see how the elbow is not being moved at all. You're going to have a medial rotation towards the midline and a lateral rotation away from the midline. Same thing for the hip joint. So if you're talking about the hip joint, you're going to be moving your hip towards the midline. That would be medial rotation. Away from the midline would be lateral rotation. Next, we have what we call special movements, which will occur at a synovial joint. And these special movements, they only occur as specific joints. We're going to have elevation and depression, protraction, retraction, inversion, eversion, dorsiflexion, plantar flexion, supination and pronation, opposition and reposition. So let's cover those in the next few slides. If we want to define elevation and depression, elevation is what we call to lift up, and depression is to press down. Therefore, the elevation is going to be a superior movement of a body part, such as when you're closing your mouth, as we can see over here on the temporomandibular joint, which is going to be the joint between the mandible and the temporal bone, and this will elevate your mandible. Or on the left side, we can see that when you shrug your shoulders at the acromioclavicular joint, which is the acromion of the scapula and the clavicle, you're going to elevate the scapula and the clavicle. Its opposing movement is what we call depression. Therefore, when you depress your mandible, you're actually opening your mouth, or when you depress the scapula or the shoulder joint, you're actually bringing your scapula back to anatomical position. There are a couple of other bones where you will have elevation and depression, and these will be your hyoid bone and your ribs. Next, we have what we call protraction and retraction. Protraction means to draw forth, and retraction means to draw back. Therefore, protraction is going to be a movement of a body part anteriorly in the transverse plane. These will also occur at the mandible. So when you protract your mandible, you're bringing your mandible forward. When you retract your mandible, you're bringing it back to anatomical position. Same thing with the acromioclavicular joint. When you protract this joint, you're bringing it forward. And when you retract, you're bringing it back to anatomical position. Next, we have what we call inversion and eversion. Inversion means to bring inward, so inversion for inward, and eversion means to turn it outward, or E for exit, to the outside. These two movements are actually very complex because they will involve multiple plane joints among the tarsal bones of the posterior part of the foot. It will not occur at the ankle, so this might be a little bit misleading, but keep in mind that this will only occur between the tarsal joints. Therefore, inversion means that you're bringing your foot inward, and eversion is when you bring your foot to the lateral side. Here we have dorsiflexion and plantar flexion. Dorsiflexion is going to refer to the bending of the foot at the ankle joint. So this would be the joint between the tibia, the fibula, and the talus in the direction of the dorsum. The dorsum is the superior surface, therefore this area here. So if you're doing a dorsiflexion, you're bringing your foot in this direction. Plantar flexion is the opposite. So you're bending your foot at the ankle joint in the direction of the plantar, which is the inferior part of your foot. Like if you're doing ballerina moves and you're standing up in your tippy toes, this would be plantar flexion. Next, we have what we call supination and pronation, and these will occur at the proximal and distal radial ulnar joint. During pronation, the distal end of the radius will be located medially. And when you do supination, it will be the opposite. You're putting the radius back in anatomical position. Therefore, the radius now is located laterally. Next, we have what we call opposition, and this will occur in the thumb. Therefore, this will occur when you bring the tip of the thumb, as seen over here, in contact with the tip of another finger. When you return the thumb to its anatomical position next to the index finger, this is called reposition. And this type of movement will occur at your first carpal metacarpal joint, which is the joint between the trapezium, which is the carpal bone that's located laterally, and the first metacarpal bone, which is the one that goes to your thumb.